Hello student, how are you? I am Arun sir. Welcome to my channel Tuition Expert. Also welcome to my NEET crash course series. Today in this class I will teach you some important problem of motion in straight line, that is called also motion in 1D. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the NEET exam confidently with a good rank. Now let's start about the class. The Here are some problems given. A car accelerates from rest at constant rate alpha for some time, after which it deaccelerates at a constant rate beta to come to rest. The maximum velocity v and distance travelled are respectively. That is, you have to find the maximum velocity and distance travelled. That is, what is the problem says? Problem says that a train starts from here. Suppose this is a train, starts from here, train or car, okay. Suppose this is a car, starts from here, equal to 0, accelerate first time. Suppose the car moves here, when rest at constant alpha for some time, after which it deaccelerates, then retardation is beta and come to rest, that is final velocity 0. Now here maximum velocity reach, time taken for this is t1, time taken for this is t2. Now you have to find the maximum velocity and total distance travel. So this is the problem. Now to solve the problem, if we draw velocity time graph of the car, suppose this is velocity and along this is time. So velocity time graph will be like this way, this and this. So this is slope of this curve is called alpha, slope of vt curve is alpha, and slope of this slope is called retardation or deacceleration. Now this is maximum velocity, now this is maximum velocity. So this is maximum velocity Vmax, and this time is t1 and t2, this time is t1 and t2, suppose, and total distance travel is x. Now total distance travel we have to find. Now from this graph we know slope of this vt graph is alpha, acceleration. Now what is alpha? Alpha equal to perpendicular by base vm by t1, and beta equal to also vm, this is perpendicular, this is base, so vm by t2, okay, vm by t1, this is alpha, this. Now from this we get vm equal to alpha t1, which is equal to beta t2. Now total time is given, total time is t is total time, here given t is total time. Now t equal to, we know t1 plus t2, so that is t1 plus t2. From this we get t2 equal to alpha by beta t1, which is t1 into 1 plus alpha by beta. So this is, now from this we get t1. Now t1 equal to what? t1 equal to beta t by alpha plus beta. So t1 equal to this. Now maximum velocity equal to this, maximum velocity vm equal to alpha t1. So answer is vm equal to alpha into t1 equal to what? t1 equal to beta t by alpha plus beta. So this is the maximum velocity. Now what is the, this is the maximum velocity. Now what is the distance travel? Distance travel, we know distance travel equal to area of vt graph, so this is half into height into base is total time t and height is vm. So distance travel equal to area of vt graph equal to distance travel, so half base into height. Now put vm equal to this, we get this result. So answer becomes D. This is the correct answer. If we put vm here, we get this answer. Now next problem is the relation between time and displacement x is this. The relation between time and displacement x is this, where alpha and beta are constant what is the retardation of the body, that is given solution of 2 given equal to alpha x square plus beta x, alpha x square plus beta x given. From this you have to find the retardation of the body. Now from this we can easily differentiate with respect to x, which is 2 alpha x plus beta, which is equal to dt by dx means 1 by v. If we so dx by dt equal to 1 by 2 alpha x plus beta, which is equal to v. So v equal to minus 1. Now if we differentiate with respect to t dv by dt, then this equal to d by dt of minus 1, which is equal to minus 1 minus 2 of, now into differentiation of this is 2 alpha. Okay, so 2 alpha. Now d by dx of into dx by dt, so this is into derivative of this equal to 2 alpha into dx by dt equal to v. So this is so 1 by this square equal to 1 by this square equal to v square, this equal to v square. So this is the answer. Moved along a straight line by machine delivering constant power. The distance moved by the body in time t is proportional to what? A body is moved along a straight line by machine delivering constant power. The distance moved by the body in time t proportional to what? Now given here power is constant power, that is power equal to constant, power equal to, what is power? Power equal to force into velocity equal to constant. Force equal to what? Mass into acceleration into v. Now m into a equal to dv by dt into v equal to k. So m into, so from this we get v dv equal to k by m dt. Now if we integrate this, then we get v square by 2 equal to k by m into t. Suppose body is rest, so if the body is rest, then constant is 0, given t is 0 equal to 0, v equal to 0. So from this we get this. Now v square equal to 2k by m t. So v equal to root over 2k by m t to the power half. Now what is v? V equal to dx by dt. We know v equal to this. So from this we get dx equal to, what? Dx equal to t to the power half dt. Okay, now this from this we get this. So integrate this, we get x equal to t to the power half. T to the power half means t to the power half plus 1 by half. So this, so from this we get x q equal to if x square. So from this we get x is proportional to t to the power 3 by 2. So this is the answer. This is constant term. So x is proportional to t to the power 3 by 2. This is the answer. X is proportional to t to the power 3 by 2. So power equal to, we first power equal to constant, power equal to force into velocity, force ma. Now acceleration dv by dt into v equal to k, v dv equal to this, integrate v square by 2 equal to this, k by m is constant t. Now v equal to root over this. So v equal to dx by dt equal to this. So if we integrate this, then we get x equal to t to the power half plus 1 by half plus 1, that is 3 by 2. 3 by 2 integration of t to the power half, this is constant, so t to the power half integration is t to the power 3 by 2 by 3 by 2. So this is x, so x is proportional to this. So 1/3 part of total distance with a speed of 20 km per hour, and second 1/3 part with a speed of 30 km per hour, and the last 1/3 part with a speed of 60 km per hour. The average speed of the car is what? Now what is that problem? Suppose total distance is x, one third, suppose this one third. Now this part is x by 3, moves with velocity. What is the velocity? 20 km per hour. Here velocity equal to 20 km per hour. Now here this moves with velocity, second part 30 km per hour, and third part x by 3 moves with velocity 60 km per hour. So what is the average velocity? Now we know average velocity equal to total distance travel by total time, t1 plus t2 plus t3. Total distance travel equal to x. Now from each part we have to find the time taken. So what is the t1? T1 equal to velocity, distance by velocity. Here distance equal to x by 3, velocity equal to 20, plus this 3 into 30, plus this 3 into 60. So this is the answer. So x is cancel. Now 30 divided by 1 by 2 plus 1 by 3 plus 1 by 6, 6 LCM, it is 3 plus 2 plus 1, that is by 6, so 30. So 30 km per hour, this is the answer. Next problem is a man in a balloon rising vertically with an acceleration of 4.9 meter per second square releases a ball 2 seconds after the balloon is let go from the ground. The greatest height above the ground reaches by the ball is what? So solution of this balloon is start from this, and after 2 seconds balloon reaches at here. Now the ball releases at here. So initially the ball gets the velocity of the balloon. So immediately the ball does not fall. Immediately the ball does not start the falling. Immediately when the ball releases, immediately it gets the velocity of the balloon. So first the ball rises and then it falls. So this is the motion of the ball. Now what is the velocity of the balloon at that moment after 2 seconds? E equal to 0 plus 80. So 0, because balloon starts from rest. So acceleration equal to what? 4.9 into 2, that is 9.8 meter per second. So this is the initial velocity of the ball upward, because the ball moving upward. Now what is the maximum height? Maximum height by the ball h1 equal to, what is h1? h1 becomes u square by 2g. h1 becomes u square by 2g. So u square means 9.8 square by 2 into 9.8, that is 9.8 by 2. This is h1. Now what is highest distance from the ground is this. Highest distance from the ground is this, which is equal to highest distance of the ball from the ground is this, which is equal to h1 plus this height. What is this height? This height will be h2 equal to distance moved by the balloon in 2 seconds, which is equal to accelerated motion ut plus half at square. By this formula we get h2. So h1 equal to 9.8 by 2 plus this equal to half a. What is acceleration of the ball is 4.9 into 2 square. So 2 cancel, 9.8. So that is 3 by 2 into 9.8, which is equal to which is equal to 14.7 meter. 14.7 meter. This is the answer. Okay. after 2 seconds the ball the distance moved by the ball is h2, which is given by ut plus half at square. This is h2 ut plus half at square, and the ball height moved by this distance, which is equal to this is and h1 equal to u square by 2g this. So total height from the ground of the ball will be h1 plus h2, which is equal to 14.7. so this is the answer. Next question. Next question is, what is the next question? The four boys are standing at the four corners of a square ABCD of lengths of side A. They simultaneously start running such that A runs towards B, B runs towards C, C runs towards D, and D runs towards A, each other with velocity V. They will meet at O after time given by this. Now, what is the solution of 2? Suppose this is a square and four boys standing at the four corners, suppose A, B, C, D. Now A moves with velocity V, B moves with velocity towards C, C moves with towards D, and D move towards D A. After what time they meet with each other? So this is a curvilinear motion. Actually, this moves. Four boys are standing at the four corners. This side A, they simultaneously start running such that A runs towards B. So B is not at rest. So B is not at, B is moving with this. That is, when B start to move, then A moves towards the B. That is, this type of motion is like this, and B also move with towards C. That means this, because C is moving and B moves towards the C. So this motion will be like this, and C also D, so this, and D also A. So this is the curvilinear motion, and the body, all the person, all the boys meet at the center. So we have to measure this. So every boy travels the distance, this distance, because four boys meet at the center. So distance moved by four boys equal to root over 2a by 2. This is the distance moved, that is a by root 2, and velocity of the boy first here this, and velocity along this component, velocity along this direction is v cos 45 degree, that is v by root 2. So the answer is time taken equal to distance by velocity. So a by root 2 by v by root 2, a by root 2 by v by root 2, that is a by b. This is the answer. So now this problem can be solved by another way. This problem can be solved by another way, alternative from this. Now alternative ways. Now A moves towards B and D moves towards this, towards A. Now this distance remains same. Now here we calculate the relative velocity of D, relative velocity of A with respect to D. Calculate V D with respect to A. Suppose VDA equal to, we know VD minus VA, VD minus VA. Now VA moves with this direction, so velocity along this direction, component of the velocity along this direction is 0. So VD equal to V minus 0, because we have to calculate the relative velocity along this direction, along AD direction. So V minus 0. Now what is the time taken? As this distance is constant, time taken equal to, suppose body, suppose A is at rest, A is rest, and the body, the velocity, the boys at here moves with velocity VDA. Now let the body, let the boy is at here rest, and the boy is at here moves with velocity A, moves with velocity VDA. So time taken equal to distance by velocity. So this is the answer. Let's, this boy is at rest. Now this boy moves with velocity VDA, which is equal to V. Now this length is constant, so time taken equal to distance by velocity this. So this was hexagonal. Suppose here is a hexagon and six boys at the corner of hexagon. 6 boys at the corner of each moves with each other with velocity v. So what is the, after what time they meet? Now if the side is A, now here we calculate this angle is 120 degree. So the relative velocity between two body along this direction we have to calculate. Relative velocity here, component of this is v cos 120 degree, which is equal to minus v by 2, minus v by 2. So here velocity of AD equal to velocity A, so velocity of dA, suppose Vd minus Va, Vd minus Va, which is equal to V minus of minus V by 2, that is 3V by 2, that is 3 by 2. That is, if the boy D is at rest, then boy A moves with velocity 3V by 2. Then what is the time taken to meet? Time taken equal to distance by relative velocity Vda, which is equal to 3V by 2. So this is the answer. So for this type of problem, we always calculate the relative velocity along this. So here the boy moves with velocity v along this direction, and velocity of boy along this direction will be v cos 120 which is equal to minus v by 2. As the two boy moves towards each other, vda equal to vd minus va. So va here, va equal to along this direction is minus v by 2, so 3v by 2. So two boy moves with velocity, with relative velocity this, with respect to one another. Now if the boy, we take the boy is at rest, then the boy A moves with velocity this. Now the distance travel, is A is constant, so time taken equal to distance by velocity, which is equal to this. So this is the answer. Two particles NB are connected by rigid rod AB such that here solution of this problem is this. Suppose this is A, this is B, this moves with this direction, so this moves in this direction. Now two particles NB are connected by rigid rod AB. The rod slides along perpendicular rails as shown. The velocity of A to the left, that is this velocity equal to 10 meter per second. What is the velocity of B when it is at angle alpha equal to 60 degree? Now this type of problem can be solved. Suppose this distance is x and this distance is y. So given dx by dt equal to Va 10, and we have to calculate dy by dt when alpha equal to 60 degree. Now from this relation we get x square plus y square equal to L square. L is length of the rod. Length of the rod is constant here because length is always constant. Length rod, rigid rod, so AB is always constant. A moves at here and B moves this. So rigid rod, as the rod is rigid and its length remain constant always, so L is constant. Now if we differentiate, we get equal to 0. So now x into dx dt, what is dx dt? 10. If we take this direction negative, so this and this direction will be positive, so minus x equal to, now we have to calculate dy by dt. So dy by dt equal to 10 x by y. Now what is x by y? Tan 60 degree, tan 60 degree equal to y by x. We know tan 60 equal to y by x, so tan 60 root 3, so x by y equal to 1 by root 3. So this is the answer, 10 by root 3. So 10 by root 3, this is the answer. This is the velocity of the end B. Now the next problem is, a body falls from rest. In the last second of its fall, it covers half the total distance, then the total time of falls is this. So a body falls from rest. In the last second of its fall, it covers half of the total distance, then the total time of its falls is what? So the solution of this problem, suppose here the body falls and this is the ground, and in the last 1 second, suppose this is 1 second, it covers this distance is half of total distance. Suppose total height is h, now this height will be h by 2. So if total time of flight, total time of its fall, time of its fall B2 BT, then what is H equal to half GT square, because body starts with rest. Now what is the H by 2? Here if total time is T, then this time will be T minus 1 second, this time will be T minus 1 second. Okay, now if the total time is T, then this time will be T minus 1 second, this time will be T minus 1 second. Now what is the velocity at here? What is the velocity? Velocity equal to U plus GT. This is the velocity at here. Now H by 2, what is H by 2? This distance travel is H by 2. So H by 2 equal to Vt, V into 1 plus half G into 1 square, because this is the distance travel in 1 second. So we have to calculate the velocity at here. So body starts with velocity v in 1 second, distance travel equal to this. Now what is v? V equal to G T minus 1 plus half G into 1 square. So this is H by 2. Now H equal to half GT square, we know half GT square equal to into half equal to G T minus 1 plus half G. So if we cancel half G from both sides, square by 2 equal to 2 of T minus 1 half G. If we common half G, then 2 plus 1. So this is the answer, half G. T square equal to 4T minus 4 plus 2, that is T square minus 4T plus 2 equal to 0. So T equal to, from Sridharachary's formula, minus B 4 plus minus root over B square minus 4AC by 2A. So this will be 4 plus minus root over 8, 2 root 2 by 2. So answer will be 2 plus minus root 2. So if we take negative, then the time of flight becomes less than 1, because 2 minus root 2. Now here, so T equal to 2 plus minus root 2. This is the 2 answer. Now if we take 2 minus root 2, if we take T equal to 2 minus root 2, which is equal to 2 minus 1.414, which is less than 1. So this cannot be, because the distance, the time taken should be greater than 1, because here the problem, it is given that in last 1 second. So 1 second is here, so the time of falling must be greater than 1. So the answer will be 2 plus root 2. In A square, solution of this problem, A square equal to AT square plus 2BT plus C. A square equal to this. So 2S into ds by dt equal to 2AT plus B, 2B. 2S into ds dt equal to this, 2AT plus 2B. So from this, ds by dt equal to velocity. So 2s into v equal to 2AT plus 2B. So what is velocity? V equal to AT plus B by S. This is, now next equation equal to F dV by dt, which is equal to d by dt of AT plus B by S. Here S is distance. Now if we differentiate by U by V method, the formula is A square, differentiate of this is A into S minus AT plus B into ds by dt. What is ds by dt? Ds by dt equal to velocity V. Now AS minus AT plus B into V. What is V? V is again AT plus B by S divided by S square. Now what is this? This will be A into S square minus AT plus B whole square, okay, by S square into S is S cube, okay. Next, this is S cube. So SQ. So if we expand this, what comes here? This is a square minus a square t square plus 2atb plus b square. Okay, this is SQ. Now this will be, what is a square? A square equal to this. Put a square here. What comes? This comes a into a square. A square is given this, so this equal to a t square plus 2abt plus ac. Now this minus a t square minus 2abt minus b square by SQ. Now if we now cancelling this, so AC minus b square is constant term, so acceleration becomes s to the power minus 3. So acceleration varies as s to the power minus 3, because AC minus b square, is constant, so acceleration is proportional to s to the power minus 3. This is the answer. Next problem is a balloon is rising vertically upward with velocity of this. A stone is dropped from it and it reaches the ground in 10 seconds. The height of the balloon when the stone was dropped from it is what? Here the question is balloon is rising vertically upward with a velocity this, dropped and reaches ground in 10 seconds. Suppose this is ground and a balloon is at here and a ball is dropped from this up. So suppose this is h from the ground. Now when the ball is dropped, this will be fall of this will be like this, and the total time, and from it reaches the ground in 10 seconds. This total time is 10 seconds. Now this velocity and this velocity remain same. The balloon is moving with constant velocity, so the balloon is moving with constant velocity and this velocity is 20 this. Now the ball when it dropped, it gets the velocity of the balloon and the velocity of the ball also 29 meter per second upward. Now if we consider the motion of the ball, then what the equation of motion? Now from this the net displacement of this equal to 0, and from this to this displacement of the ball is minus h, and velocity is upward plus into t for 10 and minus half g into t square. So equation of the motion of the ball, so this equal to minus h. Displacement is along vertical direction, displacement is along downward direction, so h equal to negative, velocity u equal to positive because it is upward, and g always vertically downward, so g is negative. Here the problem is given that acceleration versus time is given. This is t, this is a. Acceleration versus time graph is given, and when time is 11 seconds, then acceleration is 10 meter per second square. Now what is the maximum speed of the particle? What is the starts from rest, and given the particle starts from rest, that is u equal to 0. From this graph we have to calculate the maximum velocity of the particle. Now here theory applied will be area of AT graph equal to area of AT graph equal to change of velocity. This is the theory. Area of AT graph equal to change of velocity. Now what is area? Area equal to half base is 11 and time is base is 11 and height is 10. This is the area equal to change of velocity, v minus u equal to 0, so v equal to 55. So this is the answer, 55. Now the next problem is water drops falls at regular interval from a tap of 5 meter above the ground. The third drop is leaving the tap the instant the first drop touches the ground. How far above the ground is the second drop at that instant? So the problem is like this way. Suppose this is Solution 1. This is a tap. So this is a ground. This is a ground. Now 3 drops we consider. First drop when touches the ground, second drop reaches at here, and first drop, third drop just leaving the tap. Now if distance travel, this x1 and this is x2, this is x2. What is the ratio of x1 is to x2? x1 is to x2 becomes 1 is to 3. 1 is because in successive t second the distance travel for a freely falling body is, we know the theory, 1 is to 3 is to 5 this way. In successive the drops emits from the tap after regular interval. So when the first drops falls, after certain interval the second drop falls, and after that certain interval the third drop leaves. So time interval becomes same. So the distance moved by successive t second, successive regular interval of time is 1 is to 3. This is the theory for a freely falling body. This also freely falling body. Now x1 plus x2 becomes, now the height becomes 5 meter. This is given 5 meter. So 5. Now what is x2? x2 equal to x1 by x2 equal to 1 by 3. So x2 equal to 3x1. So x1 plus 3x1 equal to 5. So that is 4x1 equal to 5. That is x1 equal to how much? x1 equal to 5 by 4. That is 1.25 meter. So this is the distance x1. Now what is x2? So the question are asked that how far above the ground the second drop. This is the second drop. So the distance from the ground of second drop equal to 5 minus x1. So answer is 5 minus x1, which is 5 minus 1.25, that is 3.75. So this is the answer. What? Suppose this is a lift, the acceleration becomes, suppose f. Now a ball is thrown with a velocity v0, Now the lift moves and the ball also moves. So after t seconds, so distance moved by the ball and distance moved by the lift will be same, so that the ball returns in his hands. So the distance travel should be same, such that the ball returns the man's hand. The distance travel will be same. Distance travel by the ball and distance travel by the lift will be same. So this is the theory. Distance travel by lift equal to distance travel by ball must be same, so that the ball returns in his hands. So distance travel by lift will be what? If the acceleration is f, the ball returns in his hand after a time t. Now when the ball is projected, then the velocity of the lift, suppose u. So what is s lift? This u t plus half ft square. This is the distance traveled by lift, and the velocity of the ball projected from the lift, so with a velocity v0. So this is the velocity, actually velocity of ball with respect to lift equal to v0 given. Now what is the actual velocity of ball? This is relative velocity, that is velocity of ball minus velocity of lift equal to v0. So velocity of ball equal to u plus v0. So this is the actual velocity of the ball. So now the ball moves with velocity vv and under the gravity. So the distance moved equal to vv t minus half gt square. The velocity of the ball, actual velocity of the ball when it is projected, becomes u plus v0, because this is velocity of ball given this is velocity of ball with respect to lift. So actual velocity will be u plus v0 if u is the velocity of the lift at the time of projection. So if we cancel t from both sides, this is vb minus half gt. Now t a plus g, this here t a plus g by 2 equal to Vb. What is Vb? Vb equal to u plus V0 minus u, that is this. So t equal to the in t second, t is given, so we have to find that f. So f is 2V0 by t equal to f plus g. So f equal to 2V0 by t minus g. This is the answer, 2V0 by t minus g. So this is the answer. Okay. Falls, a particle falls h in last 60 seconds. The total time of fall of the particle is what? Suppose a particle falls from this height and falls h meter in last t second. Okay, this is h meter in last t second. Now we have to calculate the total time of flight. Suppose this time is t1, this time is t1. Then next we have to calculate the t plus t1 equal to what? Last t second means this last t second height, the distance moved by the particle is h. Now if this time is t1, that is here body falls from rest and time taken to reach this position. Suppose this is a, this is point b, this is c. Now we have to write the equation of motion in the path bc. So if we take if the velocity, so to write the equation of the path of bc, we have to find the velocity at b. Velocity at b will be u plus g into t1. So velocity at b equal to this. Now what is the equation of motion of the path bc? This path, for this path equation becomes h equal to vbt plus half gt square. Okay, this is the equation. Now h by gt, what? H by gt equal to, now put vb, so h equal to vb equal to gt1 into t plus half gt square. So h by gt, what? H by gt equal to t1 plus t by 2. Now time of fall equal to t plus t1, which is equal to t plus t1. We have to calculate t plus t1. Now t by 2 plus t1. Now t by 2 plus t1 is given h by gt. So t by 2 plus h by gt. So this is the answer, t by 2 plus h by gt. So this is the answer, t by 2 plus h by. Student, this is the end of the class today. To get such type of video and to continue the NEET crash course series, subscribe my channel. You get actual benefited. Now also there are many videos, many problems with solution are given there. You can watch this video to get more knowledge. Okay, thank you.